Modern oceans reach depths of 11,000 meters, but 80 million years ago, every 100 meters deeper meant predators with capabilities nothing alive today can match. Scientists studying fossil beds across 3 continents discovered something disturbing. The deeper prehistoric creatures hunted, the more impossible their adaptations became. The shallow zones started bad enough. Mosasaurus dominated waters between the surface and 200 meters deep, the same depth modern great white sharks patrol today. But Mosasaurus wasn't a shark. It was a 17-meter marine reptile, as long as a school bus, with jaws that opened 1 meter wide. Fossil evidence from Kansas and Morocco reveals bite marks on sea turtle shells that punched clean through 30 centimeters of bone. You couldn't outswim it because Mosasaurus reached speeds of 40 kilometers per hour using its massive paddle-like tail. Modern dolphins reach 35 kilometers per hour at best. Not to worry though, Mosasaurus was the shallow water problem. The Twilight zone between 200 and 1,000 meters deep had predators that made surface hunters look gentle. Dunkleosteus terrorized the Twilight zone 360 million years ago, long before dinosaurs existed. The name means Dunkle's bone, after paleontologist David Dunkle, who studied its fossils in Ohio during the 1950s. But here's what makes Dunkleosteus genuinely terrifying. It didn't have teeth. It had self-sharpening bone plates that functioned like guillotine blades. A 2006 study from the Field Museum calculated its bite force at 6,000 newtons, equivalent to a modern alligator, but Dunkleosteus weighed 4 tons and measured 10 meters long. The armored plating covering its head was 5 centimeters thick, thicker than a smartphone is wide, and no predator alive at that time could penetrate it. Shockingly, Dunkleosteus could open its jaws in 50 milliseconds, faster than you can blink. This created suction powerful enough to drag prey into its mouth from 1 meter away. Fossil beds in Morocco contain partially digested fish remains inside Dunkleosteus body cavities, proving it regurgitated bone rather than processing it. Talk about efficient killing. Bite, swallow, spit out the hard parts, hunt again within minutes. Unfortunately for every other creature in the Twilight zone, Dunkleosteus wasn't the only nightmare hunting at depth. Basilosaurus reached lengths of 18 meters, longer than Mosasaurus, but evolved from land mammals that returned to the ocean 40 million years ago. The fossil record from Egypt's Wadi al-Hitan reveals something disturbing about Basilosaurus hunting behavior. Researchers found juvenile whale skeletons with bite marks matching Basilosaurus tooth spacing exactly. It hunted other whales. You couldn't hide from Basilosaurus because it combined mammalian intelligence with reptilian hunting instincts. Modern sperm whales use echolocation to hunt in complete darkness. Basilosaurus' skull structure suggests similar capabilities, meaning it tracked prey using sound in depths where sunlight penetrates 0%. The teeth were designed for 2 purposes: front teeth for gripping, back teeth for sawing. Prey wasn't swallowed whole like modern predators attempt, it was dismembered methodically. But here's what makes it worse. Basilosaurus vertebrae show extreme flexibility, allowing the body to bend in ways modern whales can't match. This meant strikes came from impossible angles in 3-dimensional space where prey had nowhere to maneuver. A 2012 study from the University of Michigan analyzed Basilosaurus stomach contents and found remains from at least 4 different prey species in a single individual. It wasn't hunting for survival, it was hunting constantly. In case you needed more proof that Twilight Zone predators evolved beyond anything modern, consider the hunting success rate. Modern orcas, the ocean's current apex predators, succeed in 25% of hunts against large prey. Basilosaurus fossil evidence suggests success rates above 60% based on prey remains found in fossil beds. The oceans between 200 and 1,000 meters deep weren't ecosystems, they were kill zones. Then the midnight zone below 1,000 meters proves something genuinely disturbing about prehistoric ocean predation. The deeper you descended, the larger and stranger the predators became. Tusoteuthis measured 11 meters from tentacle tip to mantle end, as long as a city bus. But unlike modern giant squid that hunt deep-sea fish, Tusoteuthis hunted sharks and marine reptiles in the western interior seaway 80 million years ago. The fossil record is brutal. Researchers discovered ammonite shells with circular bite marks matching Tusoteuthis beak dimensions exactly, bites that penetrated 8 centimeters into solid shell. Modern squid beaks can barely scratch thick crab shells. You couldn't fight back against Tusoteuthis because each tentacle had hundreds of suckers lined with sharp hooks, not smooth suction cups like modern squid. These hooks measured 5 centimeters long and curved backward like fish hooks. Once they penetrated flesh, pulling away meant tearing muscle from bone. Shockingly, Tusoteuthis didn't need to surface for air like marine reptiles did. It waited in the darkness below 1,000 meters, where prey couldn't see the attack coming until tentacles were already wrapped around their bodies. The hunting method was nightmarish. Tusoteuthis would grab prey with tentacle hooks, then drag it deeper while the beak, measuring 40 centimeters across, worked on dismemberment. Modern giant squid beaks take hours to process large prey. Tusoteuthis beaks show wear patterns suggesting they could cut through flesh and bone in minutes. Talk about evolutionary advantage. Hunt in complete darkness, grab prey that can't escape, process it faster than anything else at that depth. Unfortunately for anything swimming in prehistoric midnight zones, Tusoteuthis wasn't alone down there. Cameroceras reached 9 meters in length during the Ordovician period 450 million years ago, making it one of Earth's earliest apex predators. The shell was cone-shaped and straight, unlike the coiled shells of later nautiloids. But here's what paleontologists found disturbing. Cameroceras had tentacles equipped with barbs and a beak powerful enough to crush trilobite shells that modern tools struggle to break. In case you needed more proof that depth meant danger, consider the oxygen levels. Modern deep oceans contain 6 milligrams of oxygen per liter of water. Prehistoric deep oceans during certain periods contained less than 2 milligrams per liter. This created what scientists call oxygen minimum zones, depths where only the most efficient predators could survive extended hunts. Tusoteuthis and Cameroceras didn't just hunt in these zones, they dominated them because their prey couldn't maintain the chase. Then 2019 research from the University of Bristol revealed something that changes how we understand prehistoric ocean depths entirely. Fossil evidence suggests certain cephalopods developed bioluminescence, the ability to produce light, not for navigation but for hunting. They would create flashes to confuse prey in complete darkness, then strike while their target was disoriented. No modern predator does this. The deeper the prehistoric oceans got, the more alien the hunting strategies became. But here's what makes prehistoric ocean depths genuinely terrifying compared to modern seas. The size progression was reversed. Today, the largest creatures like blue whales feed on tiny krill near the surface. Prehistoric oceans had the largest predators hunting at the greatest depths, meaning nowhere was safe. Surface zones had Mosasaurus. Twilight zones had Dunkleosteus and Basilosaurus. Midnight zones had Tusoteuthis and Cameroceras. Every depth had an apex predator evolved specifically for those conditions. The deepest zones also had pressure advantages modern predators can't match. At 1,000 meters deep, water pressure reaches 100 atmospheres, enough to crush an unprotected human instantly. Tusoteuthis and Cameroceras not only survived this pressure, but used it tactically. They could strike upward into the twilight zone where prey wasn't adapted to pressure changes, then drag victims down to depths where their bodies would literally compress and fail before drowning occurred. Scientists studying Cretaceous fossil beds in Kansas discovered something that proves just how dominant deep-water predators were. Multiple mosasaur fossils show bite marks from cephalopod beaks, meaning Tusoteuthis hunted creatures that themselves were apex predators in shallow zones. The food chain wasn't a pyramid with one predator on top. It was layers of apex predators, each dominating their depth zone and occasionally hunting into shallower or deeper waters for variety. No modern ocean predators operate this way. Great white sharks stay in coastal shallows. Sperm whales hunt at depth but eat squid, not other whales. Orcas dominate surfaces but rarely dive below 300 meters. Prehistoric oceans had predators that covered every depth zone with hunting capabilities specifically evolved for those pressures, temperatures, and light conditions. The survival statistics from fossil evidence reveal just how impossible these oceans were. Modern ocean food chains show roughly 10% of prey escape apex predator attacks. Prehistoric fossil beds suggest survival rates below 5% when depth-specialized predators attacked. You couldn't evolve fast enough because these predators dominated their zones for millions of years. Dunkleosteus ruled the Twilight Zone for 50 million years before going extinct. Mosasaurus controlled shallow waters for 20 million years. That's longer than modern humans have existed as a species. Temperature made everything worse at depth. Prehistoric oceans during warm periods reached 30 degrees Celsius at the surface, but dropped to 4 degrees Celsius below 1,000 meters, the same temperature difference as tropical beaches versus Antarctic waters. Predators like Tusoteuthis evolved to hunt across this temperature range, meaning they could strike into warmer shallow waters when needed, but prey from those zones couldn't survive the pursuit into cold depths. The thermal barrier worked like a one-way door. Predators moved through it easily, prey died trying. Then evolutionary arms races at each depth zone created predators with capabilities that seem impossible. Dunkleosteus developed bone plating because its prey evolved harder shells for protection. This forced prey to become slower, which made them easier targets, which meant Dunkleosteus could grow larger, which meant it needed more food, which meant it hunted more aggressively. Modern ocean ecosystems balance out. Prehistoric ecosystems escalated until mass extinctions reset everything. That's what eventually ended this nightmare. The Cretaceous-Paleogene extinction 66 million years ago killed Mosasaurus and Tusoteuthis within decades. The late Devonian extinction 375 million years ago eliminated Dunkleosteus. But for hundreds of millions of years before these extinctions, the deeper you went in Earth's oceans, the more sophisticated and deadly the predators became. Modern oceans are safer not because we evolved better defenses, but because the worst predators went extinct.